All right, BC, let's do some free response series questions. Sort of avoid them for a while. Your test didn't really have it. I didn't give you any. These can be tough questions. I think what you'll find, I mean, at first they're going to seem a lot harder, but I think you'll find that there are a lot of basic things in these. The hard thing is they're not so predictable as like other kinds of free response questions, and sometimes they have some weird stuff, some tough questions, and you're guaranteed to get 1 out of 6 of your questions in your AP tests are going to be free response. So, series questions. So let's just take a look at these and on assignment 9-4B, and see what we can make sense of them and see where the points are. I mean, that's one of the good things I think about free response questions is knowing where the points come from. So this is going to be a 9-point question. Part A was 5 points and part B was 4 points. It's from 2006, pretty old, 14 years ago, but yeah. So function f is defined by the power series. This is power series, and they're showing you the open form with the general term. Sometimes they're going to ask you to write the first 3 whatever non-zero terms and the general term, the nth term. This also is really helpful to write the closed form because essentially that's what the closed form is. For all real numbers, so converges for all, or it's defined for all real numbers, it converges. So interval converges to all real numbers. The function g is defined by this power series, so a different power series. For all real numbers, it converges. Okay, so we have that information. A says find the interval of convergence of the power series for f. Now, I guess if it says the function f is defined for all real numbers for which the series converges. Okay, so it didn't say that it converges for all real numbers. It's saying that it works for all real numbers for which the series converges. So, and because it didn't make sense that they're asking us to find the interval of convergence if they already told us it converges for all reals. It doesn't converge for all reals. Find the interval of convergence for the power series of f. Justify your answer, which probably means like showing your work in detail, which I'm having a little bit of complaint on some of you guys. I'm grading the Unit 9 test, and I generally in my test I'm expecting kind of the level of at least work and setups they expect on free response. All right, so we're gonna do so we use the ratio test. And we take the limit as n goes to infinity. Limit as n goes to infinity of the absolute value. So you need that absolute value. So then we're doing f. So you can use the nth term n -1 n plus 1 to the n plus 1 x to the n plus 1 all over n plus 2 divided by the nth term, n plus 1 on the top, multiplied by the reciprocal -1 to the nth n x to the n absolute value. Closed. So you guys set it up. And this setup is 1 point. All right, well, that's not too bad. I mean, we've been doing ratio tests. We've been finding interval of convergence quite often. Just setting it up correctly, make sure it's correct, you get a point for. Now, let's see if we can reduce any of it. So we have an x to the first. We have a -1 to the first. And I think that's it, that we can really simplify. Now, just to be careful and just to show my work a little better, I'm going to write down what we have left over. So we have a -1, we have an n plus 1 squared, and we have an x, and then on the bottom we have an n and an n plus 2. And so now we're going to take the limit. Now the dominant terms on the top are going to be n squared, and on the bottom is going to be n squared. And it's going to go to 1. So And so the absolute value of negative x, which is the same as the absolute value of x, right? Absolute value of negative is the same as absolute value of positive, and needs to be less than 1. So this is a point for applying the limit correctly, and then we're going to get -1 to 1. Now this is 5 points, right? So we still have a lot of points left. And so I believe at least comparing it to 1 or getting this, that's another point. So you got to show that work. And now there's 2 more points, and they're for the endpoints. So you got to test the endpoints. So endpoints, you probably want to make it super clear which point you're testing, that you're testing the endpoints. You rewrite the power series as a number series. So if you plug 1 in up there, we didn't even write the closed form yet. So I guess I'm going to write n equals 1 would be the first term based off the way they wrote it, the way their nth term is, and the first term that they're showing. So n equals 0 wouldn't match up to that. You could tweak it to infinity, -1 to the n, and you're only replacing x with a 1. And so we could try and clean that up. It's negative. Now 1 to the n is just n, and so it's n over n plus 1. My first feeling is that, I'm thinking, oh, this is an alternating series, but what we should always check in our head, it seems like it's usually not very rewarding. And that's why I'm just saying check in our head. What's the nth term test going to do? As n goes to infinity, does this go to 0? No, it's going to go to 1, plus or minus 1. So we're going to take, the nth term test limit as, okay, so limit as, so we want to write the name of the test as if we were trying to support, just determine if a number series converge or diverge. Limit as n goes to infinity of the nth term, -1 in n over n plus 1. And so it's going to go to positive or -1, which is not 0, which means it diverges. That's your best bet, because I don't know what else you're going to do. It's not alternating series isn't going to show anything more specific. It'd be better to use nth term test. I don't think they're integrating that. It's not a geometric series. It's not a power series. This is your best bet. So x equals 1 isn't going to work. So then we're going to do x equals -1. We're going to rewrite the power series, -1 to the n to the -1 n over n plus 1, and simplify that. And we get -1 to the 2n, rules of exponents, and that would be -1 squared to the n, which would be positive 1. So it's just going to be n over n plus 1. And so same idea. Nth term test. You got to do each one, though. Can't be, see, it's just like the nth term test, limit as n goes to infinity of n over n plus 1 goes to positive 1, which doesn't equal 0, which means it diverges. That's what we're looking for. So that's your final answer. Or you could write it, in interval notation. But 2 points for checking the endpoints and analyzing the endpoints. 2 out of 3 points. So make sure you're not forgetting the endpoints. All right. So that's now so far, that was just like any kind of straightforward power series problem we've done so far. So not too bad. B says the graph of y equals f minus g. So this is like new function comprised of those two functions, the difference of them, passes through a point 0, -1, find y prime 0, y double prime 0, determine whether y is a relative min, max, or neither at x equals 0, give a reason for your answer. Now, some of this looks like, okay, we're trying to find y prime 0 and y double prime 0, and we're trying to find if it's relative max or min at x equals 0, which means we probably are going to confirm that it's a critical point. If it's not, then it can't be a relative max or min. And then we're going to find the second derivative, which makes me think that maybe we're going to use the second derivative test for relative extrema instead of the first derivative test. I mean, those are just my gut feelings. So how do we get this information? I mean, once we get that information, I think, okay, that's AB material. Now they're giving you an XY pair here. So that's probably a Y value that maybe we're going to need for something. So there's this new function y. I'm going to write that down, equals fx minus gx. And it goes through 0, -1. And we're trying to find y prime 0 and y double prime 0 and decide if it's relative max or min. So I guess we could say, well, we have y of 0 there already. Let's try and find y prime. So what y prime would be f prime minus g prime. Okay, of course, right? So let's write down the series for f prime because we don't have a function for f. So we're going to just straight out take the derivative of each of these terms, and including the nth term. We can take derivatives of the nth term. We're taking it with respect to x, so the n's are just kind of like numbers in that situation. So the derivative of the first term is -1/2, right? Plus 4x over 3 minus 9x squared over 4 plus ... plus, not too hard, right? The -1 to the nth power is going to be whatever it is. That's just a coefficient. So anything with n's is going to stay in. And then we have an n, and then we're going to take the derivative of the x to the n right there. And so that's power rule. That's going to be in x to the n minus 1. So, right, you multiply by the power, and then you decrease it by 1. Plus ... So these are infinite series. We have the plus ... plus separating the nth term, and then plus ... at the end. So I'd write that. Now, we could, I don't know. Can we simplify this all? No. Okay, so I just wrote that, and then I'm like, okay, well, what's f prime of 0 if we plug 0 into there? Remember, this is xy. I don't think we need the y. If I plug 0 into here, all the terms with x's in it, 0, 0, and all the rest of the terms are going to have x's high powers or 0, so all you're left with is -1/2. Okay, all right. Let's do the same thing with g prime. So g prime is going to be the derivative of 1 is 0 minus 1 over 2 factorial plus 2x over 4 factorial minus 3x squared over 6 factorial plus ... plus -1 to the n times nx to the n minus 1 over 2n factorial plus ... And then we're going to say, well, g prime of 0 would be, all those terms with x's go to 0, and you're just left with -1/2. Okay, that's not bad. All right, so now let's find y prime 0 is going to equal f prime 0 minus g prime 0 equals -1/2 minus -1/2, which gives you 0. So that's one of the answers they just straight out ask you for. But we also know that means that there's a critical point right here, which is probably going to be helpful for determining relative maximums and minimums. So far, just kind of a strange question, but I just So now we're going to find the second derivative. So the second derivative, I think we're going to just try and use the same kind of strategy. Y double prime equals f double prime of x minus g double prime of x. And so then f double prime of x is going to equal 4/3 minus 18x over 4 plus, I should have said minus plus dot plus -1 to the n. And then we have an n squared times the n minus 1, x to the n minus 2, all over n plus 1 plus dot g double prime of x equals 2 over 4 factorial minus 6x over 6 factorial plus dot plus -1 to the n n to times n minus 1 x to the n minus 2 all over 2n parentheses factorial plus dot. So I'm just writing those real quick. I'm going a little quicker now. F double prime of 0 is 4/3. G double prime of 0 is 4 factorials. 4 times 3 is 12 times 2 is 24. 2 over 24, which is 1/12. Now you want to show all this work very nice and labeled and write G prime and F prime and what it equals and just be very clear here. So Y double prime at 0 is going to equal F double prime of F at 0 minus G double prime at 0, which we just calculated, 4/3 minus 1/12, which is going to equal 16/15 or 5/4 is your Y double prime at 0, something they asked you for. Now, as far as points go, they gave you a point. This is worth 4 points total. They give you a point for finding f prime of 0. They give you a point for doing this. Hopefully you should those. They give you a point. Oh, actually, I'm sorry. No. They give you a point for finding y prime of 0. And they give you a point for finding y double prime of 0. Now, by the way, this is greater than 0, which means it's concave up. And so now I'm thinking, you know what? I can't do a line check to find the first, the relative max with the first derivative. I got to use the second derivative, it's concave up, which I don't memorize, but I think, okay, if it has a 0 slope, y prime is 0 and y double prime is 0 is positive, it means it's concave up. It means it's got to be a relative min. You can see it right there. So now we just need to put this into words and say that y has a relative minimum at x equals 0 by the second derivative test for relative extrema. That's the full name. This is for your response. Now, how did that work? Since y prime at 0 equals 0 shows that y has a critical point at x equals 0, and y double prime at 0 equals 5/4, which is positive and concave up. So that's a really good answer. There's 2 points for that. 1 point for your answer, that was relative min, and 1 point for your reasoning. Okay, so that was kind of weird. Part B was kind of weird, but at the same time, like as long as you didn't get all frustrated too quick, kind of figure it out. Okay. See, let's try another one. So next one, a function is defined by, so this is kind of similar to the last one. They give you open form, nth term, general term. For all x, the interval of convergence of the given power series. So they're saying that this works for that function as long as you're on the interval of convergence, which means the series represents another function only where it converges to that function's value. It doesn't make sense to use it other places. Find the interval of convergence for power series. Show the work that leads to your answer. Okay, so again, something that we should be getting good at. Ratio test. I'm going to go a little quicker now. Limit as n goes to infinity, absolute value of n plus 2 x to the n plus 1 over 3n plus 2 divided by the nth term, 3 to the n plus 1 over n plus 1 x to the n, and probably a point for the setup. The breakdown here is 4 points for part A, 1 point for part B, and 3 points for part C, and 1 point for part D. So this is 4 points, which interval of convergence should be straightforward. So I think what you're going to learn is that even if there are some weird questions, they're usually not worth a lot, which is kind of true on all free response questions. More straightforward stuff, more regular stuff that we do a lot is usually worth more of the points. So that should be good. Let's see if we can reduce this. That's 3 to the first. That's going to be an x to the first. So just after simplifying it, without having taken the limit yet, I get n plus 2 over n plus 1. And it might be nice to kind of put those next to each other and then x over 3 over here. And then this is going to go to 1. So you're going to get x over 3 is less than 1. So usually you get a point for evaluating the limit correctly. And then a point for getting sort of the general interval of convergence without the endpoints. So I would say, well, this is the same thing as absolute value of x is less than 3. This is the radius of convergence, by the way, if they ask you for it, which sometimes they will. And, you could draw a picture if you want, or you could just, I think this one's simple enough that you guys would feel comfortable, being like, all right, it's going to be -3 to 3, but then we have to test the endpoints. And there's probably a couple test points there. So x equals -3, n equals 0, right? To get that first term. So I think we're going to write n equals 0. Because the first term doesn't have any x's on it. N equals 0. And then it's going to be n plus 1 x to the n over 3n plus 1. Now, let's just think nth term test, it passes because you have an exponential on the bottom, linear on top. So I'm not going to bother writing that down. Is it, I don't know. Hold on a second. Let's see. Nth term test. X equals -3. Did I plug in? Oh, I haven't even plugged in yet. Okay, here. So we got to plug the -3 in. That's why I was all messed up. And then we could try and simplify it. Now, you have a -3 and a +3. So that's a -1 to the n. And then you still have a 3 left over in the bottom because of the +1. So I kind of try and get that alternating part of it. Now, nth term test, it's going to blow up. So let's write that down. Nth term test, limit as n goes to infinity of n plus 1, -1 to the n over 3 equals plus or minus infinity, which is not 0, which means it diverges by the nth term test. You got to show the not equal 0. So that one doesn't work. Let's try +3 and see what we get. N plus 1, 3 to the n, plug a 3 in for the x, 3n plus 1 on the bottom. We could try and simplify this to make it a little easier. It's going to be n plus 1, 1 to the n over 3, and that's just 1. Now, again, nth term test, this is going to blow up. It's going to diverge. It's not going to go to 0. I mean, it doesn't even have to not, it's not even that, it's not just about the terms diverge, it's just they have to go to 0. So show the work, limit as n goes to infinity of n plus 1 over 3 goes to positive infinity, which doesn't equal 0, which diverges. So our final answer is that, or this, but you have to have the work for the endpoints. That's usually, at least 1 point. I think on this problem is 1 point for all that. So if you messed any of that up, didn't have it, you'd lose that point. Okay, so pretty straightforward for part A. Just be careful. Part B is only worth 1 point, so you're like, oh, that must mean it's kind of like a weird question. So let's write it down. They're asking us to take the limit as x goes to 0 of this function. So if we do that, that's the same as saying, well, let's take the limit as x goes to 0 of, and I'm going to go and just plug in f of x, the open term, just to kind of maybe give me a better idea of what's going on. And the whole thing. So I do that, and then it's minus 1/3, and then it's all over x. Now, when you plug x equals 0 in, all these terms go away, and you get a 1/3 minus 1/3, which is 0, and you get a 0 on the bottom, which is 0, which is an indeterminate form. And since this is free response, I think the burden on us is to show the work well. So we're going to say by L'Hopital's rule, and we don't want to say this equals the limit of the derivatives. We want to say the limit as x goes to 0 of the original expression equals the limit as x goes to 0 of the derivative of the top and the derivative of the bottom, which is going to be the limit as x goes to 0 of the derivative of f, which is kind of what we did last time. It's just basic derivative. It's going to be 2 over 9 plus 2 over 9x plus ... plus, and you can take the derivative here, n plus 1 times n x to the n minus 1 over 3n plus 1 plus ... Okay. And if we plug 0 in there, now this all those terms have x's, they go 0, and we get 2/9. So that was only worth 1 point. Okay, it wasn't bad. I do a little L'Hopital's rule in there. Part C says write the first 3 non-zero terms and the general term. People just don't write it. For an infinite series that represents that. So we're going to say, all right, well, let's write that down. 0 to 1 of fx dx. And that's going to be 0 to 1 of... Now, I think I'm... Okay. So I'm just going to put it in there. 1/3 plus 2 over 3 squared x plus 3 over 3 cubed x squared plus ... plus n plus 1 over 3 to the n plus 1 x to the n plus ... dx, parentheses, the dx. Let's be thorough here. And we're just going to integrate these terms term by term. Now, this is not a new thing for us. We've done this before. We've integrated certain series to get other series. This is, so this shouldn't seem like a totally weird thing. So the antiderivative is 1/3 x plus 2 over 3 halves x squared over 2 plus 3 over 3 cubed x cubed over 3 power rule plus, now they said the first 3 non-zero terms, well, we got them, and the general term plus, and you can integrate the general term, n plus 1 x to the n plus 1 over 3n plus 1 divided by the new exponent x plus 1 plus ... You should write those, and So I'm going to clean that up. That's 1/3 x plus 1/9 x squared plus 1/27 x cubed plus dot 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 plus x to the n plus 1 over 3n plus 1 plus dot dot dot. And that's my answer. And this is worth 3 points. So 1 point. Oh, now be careful. Shoot, I made a mistake. This is a definite integral. So we actually got to plug the limits in. Shoot. Okay. Well, all this cleaning up was fine. If it was 0 to x, this is what we would get. But when we plug 1 in and 0 in, now you plug 0 in, all the terms drop out. So you're just going to plug 1 in. It's going to be 1/3 plus 1/9 plus 1/27 plus dot 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 plus 1 to the n plus 1, which is 1 over 3n plus 1 plus dot dot dot. So this is our answer. I almost messed that up. And it's a point. So you got a point for integrating, and then you got a point for the first 3 terms, and then you got a point for the general term. So if you mess up one of the first 3 terms, you lose that point. There's no half points. Okay, it was kind of predictable. I guess we haven't done one really where we plug limits in, so it's kind of interesting. D says, find the sum of the series determined in part C. Find the sum of the series. You're like, what? But we don't know how to find sums of series, or I think there's only one we've done, and that was a geometric series. Is that a geometric series that resulted here? A number series? This is a number series, by the way. Times 1/3 times 1/3. Right here, you can see it. It's 1/3 to the n plus 1. That's a geometric series. So we're going to say, okay, well, that's a geometric series. And the a value, the first term, is 1/3. The r value is 1/3. I don't think we need to. Prove that it converges. So we're going to use the sum equals a over 1 minus r equals 1/3 over 1 minus 1/3 equals 1/3 over 2/3 equals 1/3 times 3/2 equals 1/2. 1 point. All right. Okay. Well, it wasn't terrible. It's a fair amount of work. Okay. Last one. Now I gotta say, these ones so far, I've seen some crazy ones, and I feel like these are not crazy. So we're gonna ease our way into this. Okay. All right. Let f be the function. So they're giving you, this one's a little different than the last one. They're just giving you a function. They're not giving you the open series, the open form of the series or the closed form of the series. Or let px be the 3rd degree Taylor polynomial for f about. That's the center. 3rd degree is the same as 3rd order. Okay. So it's not a certain particular number of terms. The last term would be to the 3rd power if it exists. If it doesn't, then previous term. So we're going to find the Taylor polynomial. Polynomial, not infinite series, not Taylor series. So it's going to not have the plus dot dot dots afterwards. It should not. And they often use P to represent Taylor polynomial. So we need some information. We need derivatives. So we have the 0th derivative, and I'm just going to write it down, and then we're going to find the first derivative, and that's going to be 5 cosine of 5x plus pi over 4. Make sure you do chain rule, and then f double prime is going to equal negative 25 sine 5x plus pi over 4. And I'm not worried about finding a certain number of non-zero terms. I'm just trying to get to the 3rd power, the 3rd derivative. So this is going to be negative 125 cosine of 5x plus pi over 4. And then we're going to plug in the center into these. So f of 0 of the original term is going to be sine of pi over 4, which is root 2 over 2. And f prime of 0 is going to equal 5 times cosine of pi over 4, which is going to be 5 root 2 over 2. And f double prime of 0 is going to be negative 25 sine of pi over 4, which is going to be negative 25 root 2 over 2. And f triple prime of 0 is going to be negative 125 cosine of pi over 4, which is going to be negative 125 root 2 over 2. Now, you want to show all this work. This is for your response. You're hoping to get all kinds of credit here. And the point breakdown of this problem is 4 points, 2 points, 1 point, and 2 points. So bulk of the points are on part A, which is something we've done quite a bit of. And probably getting the derivatives and finding them at the center. That's probably a point, another point. And then, so we're finding the third order Taylor polynomial. Okay. So it's the first number, x root 2 over 2, x minus the center to the 0th power over 0 factorial. Now that's 1 and that's 1. Plus 5 root 2 over 2, x minus 0 to the first power over 1 factorial, minus 25 root 2 over 2, x minus 0 to the second power over 2 factorial, minus 125 root 2, x minus 0 over 2, x minus 0 to the third power over 3 factorial. Don't do the plus dot dot. So that's it in kind of its ugly form. If we were to clean it up, it would look like this. It'd be root 2 over 2 plus 5 root 2 over 2x minus 25 root 2 over 4x squared minus 125 root 2 over 12x cubed. I mean, that's a little nicer version. Not that you have to simplify on free response. So, you know, if you're running out of time, especially, and be careful. B, find the coefficient of x to the 22nd power in the Taylor series for f about x equals 0. Oh, that sounds like questions I was asking you on Unit 8 test. So we want coefficient of x22. That term is going to be x minus 0 to the 22nd power, the 22nd derivative at the center over 22 factorial. The 22 factorial make up part of the coefficient. So we got to find the 22nd derivative. Now, I think there might be a pattern here that we can try and take advantage of. And and we've seen this before. When you take repeated derivatives of just sine or cosine, they keep it's sine, cosine, negative cosine, sine, cosine, negative cosine. So if we divide out all the 4s, and the remainder tells you that this is the same as the second derivative, okay, as far as it's going to have a negative, the 22nd derivative is going to have a negative 20, or it's going to have a negative sine of 5 pi plus pi over 4. And then the next one was 5 to the 0, 5 to the first, 5 to the second. It's going to have a 5 to the 22nd. And I think it might be okay to just leave that. I don't think you want to figure out what 5 to the 22nd power is anyways, but it's going to be negative. And then we're going to plug 0 into that. And so it's going to be negative 5 to the 22 sine of pi over 4, which is going to give you negative 5 to 22 root 2 over 2. And so then our answer, the coefficient, is going to be negative 5 22 to the 22nd power, and not in parentheses, root 2 over 2 times 22 factorial. I think we should just leave that answer like that and not try and clean it up. Okay, that was 2 points. You guys could totally do that. C, use the Lagrange error bound. Oh, you guys' favorite. Now, this is, I want you guys to get used to seeing this, because a lot of times they don't even say Lagrange error bound, or they don't even say anything about error. They give you something like this. You should recognize that's the error, because this is the actual function, right, minus the estimate Taylor polynomial, the actual minus the estimate, the difference is the error, absolute value. This represents error. So if you see that without them even saying error, you need to be like, oh, that's error. Okay. Now they're saying to show that it's less than 1 over 100. So they're kind of like, it sounds like they're telling us the answer and we need to figure it out. So we're trying to Lagrange error bound, and we're trying to show that f of 1/10 minus p at 1/10 is going to be less than 1 over 100. So let's break out our Lagrange error bound knowledge. Lagrange error bound is the absolute value of the n plus 1 derivative at a c value, x minus the center to the n plus 1 power over n plus 1 parentheses factorial. So in our case, they're saying, are we trying to use what derivative are we at? So I think we're we're using the Taylor polynomial that they've been referring to already. So from part A, so that was a third degree, third order. So we want to do fourth derivative at C. The x value is 1/10. That's what we're plugging in, right? That's what they're showing right there. We're plugging in 1/10 minus the center is 0 to the fourth power over 4 factorial. And so now we got to figure out this value here. So this is where C is between the center and the value we're evaluating at. In this case, C is between or equal to 0 and 1/10. Those are things you should write down in your work. And now we got to just figure out what that value is. So I'm gonna make a little graph. I think that would be sufficient. Sometimes they actually just give you graphs, and the graph's already done for you. So the fourth derivative, which we hadn't found yet, so the fourth derivative of x is positive 625 sine of 5x plus pi over 4. So that graph is a sine curve. The period's been divided by 5, and it's been shifted to the left pi over 4. So usually the sine curve would look like this, and this would be 2 pi, but it's going to be divided by 5. This would be pi. This would be divided by pi. The amplitude is 625 to negative 625. And maybe I should try and be clear and be like, this is the fourth derivative, and this is x. Now it's been shifted to the left pi over 4. Okay? So this is pi over 5. This peak right here, so the graph, let's see, that's pi over 5. So this would be at pi over 10. And so if we shift this over, and this is at 3 pi over 10, because that would be 4 pi over 10. So if we shift over pi over 4, how does that compare to these? That would be 10/40ths, right? And this would be 4/40ths, and this would be 8/40ths, and this would be 12/40ths. So that's 12/40ths right here, and we're shifting over pi. I'm going to just move the axes. So pi over 40, that's 8 pi over 40, and that's 12 pi over 40. So it's going to be like right between those. That's your new axis with the shift. So this is kind of tricky because of that shift. And we're trying to find the worst value from 0, which is going to be right here, to 1/10, or 4/40ths. Now this would be 16 pi over 40. So we're at 10 pi over 40, and we're going to go to we're going to add 1/10, which would be 14 pi over 40. So that's definitely going to be somewhere like right here. So, man, this is kind of tough. So that's the chunk of the graph we're looking at. So I'm pretty sure we capture that negative 625. So let's write down what we get. We get absolute value of negative 625. Right, that's just going to be that's just going to be the amplitude. 1/10 to the fourth power over 4 factorial. We're trying to convince them that this is less than 1/100th. So I guess we got to try and do the work. Negative 625 times, let's see, 4 times 3 times 2 times 1 times 10 times 10 times 10 times 10. I mean, let's see how far we can get. I don't know if this is necessary, but we'll see. We could take a 5 out of this, it'd be 125. We could take another 5 of this, that'd be 25. Take another 5 of this, that would be 5. Take another 5 out of it, that would be that. So we're down to, and the negative goes away. So we're down to 1 over whatever this is. Okay, well, that's going to be 12 times 2 to the 5th. 2, 4, 8, 16, 32. 4, 6, 0, 2, 3, 6, 8, 3. So this is 1 over 384, which is for sure less than 1 over 100. And we've proven it. Oh my gosh. So, I mean, Lagrange error bound is usually kind of tough and tedious, but that one was like even worse than normal. But there you go. 1 point though. It was only worth 1 point. So probably don't spend as much time as I just did unless you finish everything else. Now, part D says, let G be a function that is the integral of our other function from 0 to x ft dt. Write a third degree polynomial for G. So we're going to integrate another function. So let's write the series that we were creating, the Taylor polynomial for this. So we can integrate one Taylor polynomial to get another Taylor polynomial. Just like we integrate one series to find another series. So the terms that we had originally, let's just write down, we got root 2 over 2 plus 5 root 2 over 2x minus 25 root 2 over 4x squared minus 125 root 2 over 12x cubed plus dot, dot, dot. And I'm not going to write the nth term because they didn't ask us to write the nth term. We're trying to find the third degree Taylor polynomial, which means we only need the second degree term here to get the third degree term if we're integrating, because when you integrate, the power is going to go up. So that's going to be root 2 over 2x. And this is a definite integral. Plus 5 root 2 over 2 x squared over 2 minus 25 root 2 over 4 x cubed over 3. And that, that's good enough. And so we're going to get, and we're going to plug x in and plug 0 in. So we're going to get root 2 over 2x plus 5 root 2 over 4 x squared minus 25 root 2 over 12x cubed. And this is the Taylor third degree Taylor polynomial for G. Don't put the plus dot dot on the end. It says this is worth 2 points. Subtract 1 point for each incorrect or missing term. Subtract 1 max for extra terms or misuse of equality. So if you gave too many terms, you lose a point. If you're missing a term or get one wrong, you lose a point. So there you go. I thought that was a pretty good sneak, preview of free response with series.